everybody, this is S. Raji going to teach you the concepts of 12th standard physics. In the first two chapters of the 12th standard physics, we will be studying about the first chapter is electric charges and fields and the second chapter is electrostatic potential and capacitance. So in the first two chapters of 12th standard physics, we will be studying about electrostatics. Okay. So what do you mean by the word electrostatics, children? The word electro means charges. The word statics means at rest. So in the first two chapters, we are going to study only about the charges at rest. We will keep the charges at rest and we will be studying about all the phenomena related to charges at rest. And the first two chapters will be dealing only about charges, force between the charges, field produced by the charges, potential around the charges. Then the last one will be capacitance of capacitors. Okay, so these are the 5 concepts which we are covering in the first two chapters. And in your first chapter, we will be studying about the first 3 concepts, that is charges, force and field. Okay, so now first of all, let's study about the charges first. Okay. So why is it important that in the first two chapters we are studying about the charges at rest? Why are we keeping these charges at rest? See, I will tell you with this with an example. Say for example, you want to measure the mass of a person. Okay, right? So tell me which one will be easier, children? If you want to measure his mass or his height, whatever it is, it will be easier for you if the person is at rest, right? If the person is standing, then it will be easier for you to measure his mass, his height, everything. But when the same person is made to run and simultaneously if you measure his mass or weight, it is possible, but it will be little bit difficult, right? The same concept here also. So first of all, we are going to keep in the first two chapters, we will keep the charges at rest and we will be studying about the phenomena related to the charges at rest. And from the third chapter onwards, what are we going to do? We are going to make these charges to move. That is, we are going to study about electricity. Okay, we will start studying about electricity from the third chapter where these charges are going to move, right? So first of all, let's keep these charges at rest and study the phenomena related to them so that it will be easier for us when we start studying about a current electricity, that is charges in motion. Okay, so that's why the first two chapters are based on the concepts of electrostatics. Okay, children. So now the charges. So there are only two basic entities, that is positive charge and negative charge. Okay, right? Negative charge. In your 10th standard itself, we have studied that there are two types of charges, positive charge and negative charge. Positive charge and negative charge. Okay, charges are represented as Q, right? It can be represented as small q or it can be represented as capital Q also, right? Sometimes they will also represent it with capital Q. And what is the unit for charge, children? The unit for charge is coulomb. These things you have already studied in your 10th standard. Okay, right? So there are only two basic entities, that is your positive charge and your negative charge. Okay, right? So the these charges, when they are at rest, we say that it is electrostatics. Okay, and these electrostatic concepts are used. We can see this electrostatic concept in our day-to-day life itself, children. Right? This you would have experienced by yourself. Say when you touch a doorknob, okay, when you touch a doorknob, sometimes you would have felt a little bit of shock flowing in your body. Okay, what is the reason for that shock, little bit of shock when you touch the metal doorknob? Okay, the doorknob should be made up of metal, remember that. See, when the doorknob is made up of metal, what might happen is sometimes the doorknob might be containing large amount of positive charges, okay, right, with a few number of negative charges. When you touch the doorknob, what will happen? You know that our body is a good conductor. good conductor of electricity. So what will happen? Electrons will flow from our body to the doorknob to neutralize those positive charges, right? So when the electrons flow from our body to the doorknob, a little amount of shock, right? A little bit of shock will be experienced by you, right? And also in lightning also, the electrostatics concept is based, okay, lightning is also based on the electrostatic concepts only. So see, say for example, this is your cloud, okay, right? So inside the cloud, positive and negative charges will be there. So what will happen is they will be getting separated, okay, right? The positive and negative charges will be getting separated. Usually the positive charges will move to the upper part of the cloud and the negative charges will go to the down part of the cloud, okay, right? When this goes on, what will happen? More amount of negative charges will start accumulate in the lower part of the ground. When it exceeds certain limit, what will happen? This cloud will start to discharge its charges, okay. So when it is discharging, what will happen? You know that earth is always at a zero potential. So what will happen? These negative charges will flow towards the earth, okay, right? And this is what you call it as lightning, okay. This is what you are calling it as lightning, right? So this is also, this lightning also is because of the electrostatic concepts only. That is, the charges are building up, right? Static charges are building up. When it exceeds a certain limit, they flow to the ground, causing lightning effect, okay. So in our day-to-day life itself, we are experiencing this electrostatic concept, right? So that's why it's very, very important for us to know about the charges at rest, okay, children. So the first concept I told you, it is charges. So how can you say that there are two amount of charges, children? That can be done with a small experiment. See, this is a system, okay, right? This is an isolated system which we have considered. What do you mean by isolated system? An isolated system is a system in which number of charges will be kept constant even if time goes by, okay, right? I'll tell you that. Wait. So this, in this isolated system, this is a glass rod and this is your silk cloth, okay. Now what I'm going to do is I'm going to rub this glass rod with the silk cloth, okay. When I rub the glass rod with the silk cloth, what will happen, children? You know that there will be a frictional force between the glass rod and the silk cloth, okay. Because of that frictional force, what will happen is this silk cloth will become negatively charged, okay, and this glass rod will become equally positively charged, okay. Remember what I am telling you, silk cloth is becoming, when you rub them together, what is happening? The silk cloth is becoming negatively charged and the glass rod is becoming equally positively charged, okay, right? So how many number of electrons I have drawn here? The same number of positive charges also I have drawn it here, right? See, when I rub them together, what will happen is, see, negative charges from the glass rod will get transferred to the silk cloth, okay. Negative charges from the glass rod will get transferred to the silk cloth, making it more negative and making this glass rod deficient of negative charges, right? The deficiency of negative charges is being represented as the positive charges, right? So now the glass rod, in our example, the glass rod is now deficient of 4 negative charge, so it is more of 4 positive charge, right? So that's why I have told you that it is becoming equally positively charged, okay, right? And always you will find that these negative charges only will be moving from one place to another place. See, which one is more heavier, your proton or your negative charges, that is electron? Electrons are lighter, right? They are of less mass. So as they are less mass, what will happen? The probability of the electrons to move from one place to another place is high, okay. So that's why whenever we talk about these things, we say that electrons are moving from glass rod to the silk cloth, right? Not the positive charges are moving from silk to glass rod, okay, right, children? So now in this isolated system, glass rod and silk cloth, when we rub them together, the silk cloth is becoming negatively charged and the glass rod is becoming equally positively charged, okay, right? So now in the system, say for example, the amount of charge is equal to, say for example, 10 coulomb, okay, right? So at time t1, the amount of charge is 10 coulomb, Okay, right? At time t2 also the amount of charge will be 10 coulomb, and at time t5 also the amount of charge will be 10 coulomb. Okay, right? So what does it mean, children? Even if time passes by, the amount of charge in the system is not changing. Okay, right? So charges are not neither getting into the system, charges are neither not getting out of the system, right? So the amount of charge present in the system is kept constant. Okay, right? So such a system is called as an isolated system, right? But remember, charges get transferred from one part of the system to the another part of the system. That's not an issue, but altogether from the system, charges are not coming out and charges are not getting inside. Okay, right? So such a system is called as your isolated system. Okay, children? Similarly, there is another one example with plastic rod and fur cloth. Okay, right? Now when you rub the plastic rod with the fur cloth, here you will find that the fur cloth is becoming positively charged and the plastic rod is becoming equally negatively charged. Okay, so in this case this is also an isolated system only. So what is happening in this example, children? When I rub this plastic rod with the fur cloth, what is happening? Electrons are being transferred from the fur cloth to the plastic rod, right? As the probability of the movement of electrons is higher, negative charges go to the plastic rod, and as there is a deficiency of 3 negative charges here, the fur cloth is becoming positively charged. Okay, right? So here also the charges are being transferred from one part of the system to the another part of the system. Okay, right? So in these two experiments we have shown that there are two types of charges, positive charge and the negative charge. Okay, right? So what do they do? You know that like charges will like charges will repel unlike charges will attract. Okay, so to prove this, they have done a simple experiment for you people. They have shown a simple experiment. So from a silk thread, okay, right? From a silk thread, I'm hanging a charged glass rod. Okay, right? So from the silk thread, I'm hanging a charged glass rod, right? So as the charged glass rod means it will be of positive charges only. Okay, now nearer to this charged glass rod, I am bringing another one charged glass rod. Okay, right? Both of them are glass. So glass rod means you know that this will be of positive charge only, right? So when I bring another one charged glass rod near to this charged glass rod, it is found that the hanged glass rod is moving away from this charged glass rod. Okay, right? So this proves that like charges will repel each other. Okay, right? Similarly, what I can do with the help of a silk rod, I can hang a charged plastic rod. So if it is a plastic rod, you know that it will be of negatively charged. I am bringing another one charged plastic rod. Okay, so when I bring this charged plastic rod, what will happen? You know that this hanged plastic charge will move away from this one. Okay, now I'm hanging a charged glass rod and I am bringing another one charged plastic rod. Okay, plastic rod. Okay, now what will happen now, children? Now you will find that this glass rod and plastic rod are attracting each other, right? They both will be moving towards each other, right? So this is a simple experiment to prove that like charges will repel and unlike charges will attract each other. Okay, and you have one more experiment with the help of your glass rod and your pith ball. Okay, so see, this is a conducting rod, and from this conducting rod I'm hanging two pith balls. Okay, I'm hanging two pith balls. Now what I'm going to do, I'm going to touch this conducting rod with the help of a charged glass rod. Okay, when I touch this conducting rod with the help of a charged glass rod that is positively charged, what will happen? This is a conducting rod, no? What will happen? These positive charges will move into the conducting rod, and from the conducting rod they will be moving to the pith balls. Okay, so both the pith balls will be getting positive charges. As they both are getting the positive charges, you will find that they both will be moving away from each other, right? This can be shown with the help of a plastic rod also, charged plastic rod also. In that case, from the negatively charged plastic rod, the negative charges will flow to the pith balls, and the pith ball will become equally negatively charged, right? Again you will find that these two pith balls will move away, right? This is the case when we touch the rod when we touch the conducting rod with the help of a charged plastic rod. Okay, right? So now the same conducting rod, one side we are touching it with charged plastic rod, and another side we are touching it with charged glass rod. Now you will find that this pith ball will be getting negative charge and this pith ball will be getting positive charge, so they will be attracting each other, right? And they will join together and hang from the conductor. Okay, so this is also an experiment to prove that the two charges, like charges, will repel and unlike charges will attract each other. Okay children, so altogether what is happening, there are only two types of charges, positive charge and negative charge. Okay, right? Now before rubbing, what is happening before rubbing? Before rubbing, the glass rod as well as the silk cloth, okay, glass as well as the silk cloth, right? Both of them were neutral. Okay, both of them are neutral, right? Now when you rub them, what will happen? After rubbing, what will happen? This glass rod is becoming positively charged and the silk cloth is becoming equally negatively charged. Am I right? Now see, after rubbing them and leaving, now when you touch this glass rod with the silk cloth, what will happen? The positive and negative charges get neutralized and again they will become just a glass rod and a silk cloth. Okay, right? They are not charged now, right? They don't have any charges now, they are neutral, right? So here also they are neutral and here also they are neutral. Okay, right? So what is happening, children? The negative charge and positive charge are neutralizing each other when you touch them together. Okay, now in this case, see, the glass rod, I told you, no, it is becoming charged, right? So you have to use the word charged or electrified. Okay, the glass rod has become charged or electrified. The silk cloth has become charged or electrified. Usually we don't have the habit of using the word electrified, we will be always using the word charged only, right? So the glass rod has become positively charged and the silk cloth has become negatively charged. Okay, right? So these are the few concepts about the charges which we should know. Okay children, right? Thank you. If you like the video, subscribe for more videos.